In this video, we are going to practice solving a systems of equations involving a quadratic function. So we're going to solve f of x equals g of x and find the points of intersection of the graphs of the two functions that are given. All right, let's look at the first one. And here we have two functions, f of x and g of x as written. And so we want to solve f of x is equal to g of x. So we're just going to write down what f of x, we'll start with f of x equals g of x, and we're going to replace f of x and g of x with what they're equal to. And we're going to solve for x. Now in this case, we normally, when we have a quadratic equation, we want to get everything to one side of the equation with a 0 on the other side. So I'm going to get rid of this 3. These cancel out, and these cancel out. Now sometimes people get confused about what to do on the right hand side, but 3 minus 3, remember, is just equal to 0. On the left hand side, it might be a little confusing too, because we're used to having ax squared plus bx plus c, but we're missing a number term. But remember, if you're missing a number term here, it's actually very easy to factor, because we just factor out an x, and what we're left with is x minus 4 inside the parentheses. So this means that either x equals 0 or x minus 4 equals 0. And I'm just going to add 4 to both sides. And we get our final answer. Now, we need to find the points of intersection. But this is actually pretty easy, because we know that no matter what the x value is for g of x, the y value will always be equal to 3, right? Because g of x is just every point where the y value is 3. So our points of intersection are going to be 0, 3, and 4, 3. Let's go to Desmos and make sure that we did this correctly. And so we'll say g of x equals 3. That's our first. We'll do y equals 3. And the other one was x squared minus 4x plus 3. Hit enter. And our points of intersection are 0, 3, and 4, 3. As we see, we got that correct. Now, you could have also just plugged in 0 and 4 into the equation x squared minus 4x plus 3. You would have gotten the same answer. All right, let's do B. And again, we want to solve the equation f of x equals g of x, so I'll just start with that, and we're going to plug in for f of x and for g of x. And what I'm going to do is I'm just going to move everything from the left-hand side over, everything from the right-hand side over to the left-hand side. And making sure I change the sign as I do that. All right, and I'm going to go ahead and combine the like terms at the end. And now we have an equation, and we need to solve for x. I think probably the easiest way to do this would be to use the quadratic formula. Often, if there's a number in front of the x squared term, I will decide to use the quadratic formula. As opposed to trying to factor it. The nice thing about the quadratic formula is that it always works. All right, so let's see. This is going to be opposite b. So negative 10 is b, so that'll become positive 10 plus or minus the square root of negative 10 squared minus 4 times 3 times negative 8. And this is all over 2 times 3. So this is going to be 10 plus or minus the square root of 100, and 4 times 3 times 8, or negative 4 times 3 times negative 8, is 96. And it's going to be a positive 96. So x equals 10 plus or minus the square root of 196 divided by 6. Now, I'm going to take the square root of 196. It actually ends up being a whole number. That the square root of 196 is actually 14. And so now I split this into two solutions. X 10 plus 14 divided by 6 and 10 minus 14 divided by 6. So this ends up being 24 divided by 6 and negative 4 divided by 6. 24 divided by 6 is 4. And I'm going to just simplify this to 2/3. So those are my two possible answers. Now, if I want to find the points of intersection, I need to go back, and I'm going to choose one of these equations, and I'm going to plug into it. G of x seems easier to me, so I'm going to plug in to g of x. So g of x equals 10x plus 1. So this would be 10 times 4 plus 1, which is 41. So one of my points will be 4, 41. And the other one, let's see, we could do g of negative 2/3 equals 10 times 2/3 plus 1. And that is going to end up being, I'm going to convert this into a fraction, so that's going to be 20 divided by 3. And I'm going to convert this to a fraction as well. This ends up being 23rd and 3rd. So my points of intersection should be 4, 41, because when I plug in 4, my output is 41, and negative 2/3, 23/3, which will be about 7.6 if I'm not mistaken. All right, let's see if we did this correctly. So I'm going to go back to my original. We'll go to Desmos. So we have 3x squared. Let me get rid of these. 3x squared, I think it was minus 7, and 10x plus 1. All right. So here again you see negative 2/3 and negative 5 point. So is that correct? I feel like maybe I got that wrong somehow. Let's see. I'm just going to divide 23 divided by 3, and I get, again, 7.6. I see where I made my error. I was supposed to plug in a negative 22/3. I plugged in positive. So then this becomes negative, which means this ends up being negative 17/3. Now, if I do set negative 17, so this should be about negative 0.6 repeating, comma, and 17, negative 17 divided by 3 is what we want. So that's why it's important. Always check your work. It's easy to do with Desmos. And we can see that now we have the correct answer. And then our other Point of intersection is all the way up here, but it should be 4, 41, and we did that correctly. All right. And again, even people like myself who are college professors in mathematics sometimes make simple errors, like they forget to plug in a negative sign. But what's important is you learn how to check your own work so that you can easily decide, did I do this correctly or did I make a mistake? And then go back and find your error, which is what I did here. All right, we have one more problem that we're going to try. Which is part C. So for part C, again, we'll start with f of x equals g of x. We'll plug in both of our numbers, or our equations. And I'm going to move, in this case, everything to the right-hand side so I avoid having a negative x squared. If I moved, for example, the 2x squared, I would end up with a negative x squared on the left. I want to avoid that. So what I'm going to do is I'm going to really get rid of everything on this side of the equation. So I end up with a positive x squared. And these all cancel out. I'm left with 0. This ends up being x squared minus 2x minus 15. And here I see that I can factor because I can think of two numbers that multiply to get negative 15 and add to get negative 2. Can you think of what these numbers are? Pause the video real quick and see if you can figure it out. All right, and you should have, if you were able to figure it out, you should have gotten x minus 5, x plus 3. So x equals either positive 5, well, let's see, x minus 5 equals 0, or x plus 3 equals 0. And I can solve both of these equations rather quickly. So x equals 5 or x equals negative 3. All right, again, I want to figure out my points of intersection, so I'm going to choose either f of x or g of x. I think f of x looks easier to plug into, so I'm going to use that. So first let's plug in f of 5. 5 squared minus 5 plus 1, that's going to be 25 minus 5 plus 1. That's going to be 21. And f of negative 3 is going to be negative 3 squared minus negative 3 plus 1. Negative 3 squared is 9. This double negative becomes a positive number, and then this becomes 13. And so our points of intersection should be 5, 21, and let me write this down first. The other one would be negative 3, 13. All right, let's see if we did this one correctly. So x squared minus x plus 1. I'm going to actually reset this real quick. X squared minus x plus 1. That's our first one. And our second one was 2x squared minus 3x, and I think it was minus 14. All right, let's see where these intersect. First one is at negative 3, 13. We did that one correctly. Hopefully the next one will be 5, 21. It's looking promising. And we have 521. And so we did that correct. All right. And so that, my friends, is how we do problems. That's how we solve systems of equations involving a quadratic function. Hope that was helpful, and we will see you in the next video.